So far in our class, we've covered 4 types of inheritance: complete dominance, incomplete dominance, codominance, and sex-linked traits. We've also studied pedigrees. We're going to do an example problem on complete dominance, and I'm going to show you step by step how you want to do the problem. Here's a simple problem: black fur in guinea pigs, which is capital B, is dominant over white fur. Find the probability of black offspring in a cross between capital BB and lower b. First thing we're going to do is set up the problem. So that's step 0. Okay, so you write step 0, and we want to write all of the possible genotypes, and there are 3 in this case. Okay, we have what we call homozygous dominant, capital B, heterozygous, and homozygous recessive. Recessive. Okay, you want to in the beginning probably write the words until you get to know them. It's a really good habit to write the word completely: homozygous, dominant, heterozygous, and homozygous recessive. I wouldn't skip that step because these are probably the most important words in genetic pedigree Punnett squares. If you don't know those words, it's going to be very hard sometimes. So first, with the genotypes, we labeled homozygous dominant, heterozygous, which is 2, a capital B and a lower b, and homozygous recessive, 2 lower case. Okay. Now we're going to put the phenotypes. This one would be black fur, black. And this one would be black too because the big B is small, dominant over the smaller b. And these are 2 alleles of the same gene. The gene is the trait, and this is the black fur and the white fur. But this one's dominant, so we put black as well. And then this one is recessive, so this is white because they have 2 little r's. White. Now, one thing I like to do here is to create a little system. I will later show you why this is important. I will circle this. I'll put a dot by the actually, because they're both black, I'm going to circle both, and I'm going to put an X by the last one. This will come into play later. So now we have step 0, which is the setup. When you get really good at this, you won't have to do that, but I would really recommend doing this in the beginning. Step 1, find the parents, probably the most important step, and we know it because it told us, but let's pretend it didn't tell us. It would ask for, you're going to cross a heterozygous guinea pig with a homozygous recessive guinea pig. What is the chance of black offspring? Okay, so we would find the parents, parental cross, and that is going to be BB times BB, and that's because it told us in this case. So we know the cross. Now step 2 is set up the Punnett square. So first find the parents, then make your Punnett square. And it does not matter which one you put on the top or the side. I tend to put this one over here. So I'll put this like this, and this right here. You could do it the other way. It wouldn't matter. Now as we do this, we're going to put a big B in here, and then a small b. Big B goes here, and then a small b goes here. Small b in both, right? Small b to one here and one here, okay? The conventional way of doing it is always put the dominant first, okay? If there's a choice, you want to put the big B first and then the small b. Now we have the Punnett square finished. Let's see what kind of phenotypes we have in here. So we're going to look up here at our key, and because we've already made it, it's easy, right? And that's why we do it first. We know if we have heterozygous, it's going to be black, and we're going to circle it. We're basically circling all the black ones. Heterozygous again, we're going to circle it. And if it's homozygous, recessive, then we're going to put a star. And look at this, I messed up here. This should be little b's. There. So little b's, we are putting a star by. If I do these steps like this, it's much more likely I'm going to get the problem right. Let's go to step 3. This is where it can get a little confusing if we haven't done these steps. This is called a genotypic ratio. Typic ratio. And the first thing we do is we put the possibilities. So BB, B, little b, and little b, little b. Okay? Now we just count. How many big B's do we have? We have 0. How many of these do we have? We have 2. How many of these do we have? We have 2. There's our genotypic ratio. This would be 50% this, B, B, and 50% B, B. That's our genotypic ratio, geno being genes, right? The phenotypic ratio, and phenotype means physical trait, and phenotypic ratio. And we only have 2 phenotypes, and that is going to be black fur or white fur. And both of these would have given us black fur, right? So how many black fur? We look for the circles. We have 2. And how many stars do we have? Because we know that the recessive is the star, right? So we have 2. So we have 50% black and 50% white. So the answer to the question is, we'll find the probability of the black offspring in a cross between these 2 genotypes. And we know that that would be 50%. But it's always good to check your answer. And the way we do that is you want to go backwards, because if you go the same direction, you're probably not going to catch anything you did wrong. But if you go backwards, you're going to see things differently, and you have a better chance of catching any mistakes. So I made this little checklist. Did I count the genotypes and phenotypes correctly? So I counted 2 and 2 and 2 and 2, and I think I counted, because this is black, so that's 2. This is white, that's 2. Got that correct. 2 of these, 2 of these. So got that correct. Okay. Genotype and phenotype correct. Did I label the phenotypes correctly? So did I put the stars and the circles correctly? Star, star, right? And then I wanted to circle the heterozygous or big B, homozygous dominant, and that I did that correct. Okay. Did I perform the Punnett square? So did I drag these B's in here correctly? And I did, right? So that's correct. And the most important check is for your parents, okay? Because if you get the parents wrong, the whole problem is wrong. So the way you do this is you go back to your parental part. This is the parents we used, and you say it, okay? So this is a heterozygote, which would be black fur, but a heterozygote, and this would be a white fur, and a homozygous recessive. I say that, and I go look at the problem, and I find that. And because the problem is a simple problem, they gave it to us, so they didn't say it that way, but we got it correct. So we're checking always. So as long as I got the parents right, and I did the Punnett square correctly, I labeled the phenotypes correctly, and then I counted them correctly, I'm probably going to get the right answer. So those are the steps you want to take when you do every Punnett square, and you're probably going to want to write, well, you do in the beginning want to write step 0, 1, 2, 3, and 4. And you want to write it out. You want to take your time and write it out. Even write setup, Punnett's parent, parental cross, Punnett square, genotypic, phenotypic, and check. You want to write the steps every time so that you get it correctly, especially when you're first learning. All right, I hope that helps. Like I said, you can find this worksheet online, and use this technique when you answer your other problems.